two types of sensory signals. Spinocerebellar, also two in each side. Yeah, ventral and dorsal, front and back. And spinocerebellar tract takes signal to the cerebellum. Now, cerebellum is the part of your brain that maintains balance, equilibrium. Okay? So, what kind of signal is taken to the cerebellum? Body position. If your body tilts, signal will go to the cerebellum, right? We'll tell the cerebellum, fix it. You are falling. Okay? So, makes sense? So, spinocerebellar carries the body position. Right now, your body is in what position? Okay? Which position? That signal is taken by the spinocerebellar tract. Is it clear? Difficult? Okay. So, the last one in the back. There are two, fasciculus gracilis, fasciculus cuneatus. These are also sensory tracts in the back part of the white matter of the spinal cord. They carry fine and crude touch. So touch. Now touch could be soft touch, right? If I gently touch your skin, that will be carried by one tract, and deep pressure or crude touch, okay, will be carried by another tract. So just know that these two are for fine and crude or deep touch.
Which is which?
The fasciculus cuneatus is fine touch and gracilis is crude or deep touch. Okay? Now, remember, these are important sensory tracts. The most important motor tracts are called cortico-spinal tract. Cortico-spinal tract. The most powerful motor tract. Why? Because this tract takes the signal to the skeletal muscles and controls the movement of the body, voluntary movement. Corticospinal tract has another name. If I ask you, corticospinal tract is also called pyramidal. Tract. Okay? Same thing. Other motor tracts are, so let's see the corticospinal. You see this is the this is one lateral corticospinal tract and the ventral corticospinal tract. The ventral corticospinal lateral, same thing here. Now, other motor tracts are rubrospinal. You see all end with the spinal. Rubrospinal, reticulospinal, vestibulospinal, tectospinal. All those are motor tract because they end with spinal. Just remember the most important one, most powerful one. That should be.
Any tract we do have lateral and ventral. They do the same thing.
Yes, because you know the position, ventral front, lateral and dorsal. Okay. Okay. Now, I told you at the very beginning, if I touch your skin, the signal, sensory signal, will be taken to the brain, right? It is far. One neuron length is not enough to take the signal all the way to the brain. Make sense? That's why you have what? I said? Yeah. A number of sets of neurons. Relay takes place. Remember that? One group of neurons will take the signal up to a certain distance and will give the signal to another set of neurons that you take up to there, okay? And then that way it will reach to the brain. So in ascending pathway, you already know, you see here, if I touch the skin here, the signal will go this way, you already know that. And which neurons are here? Sensory neurons located in the dorsal root ganglion. Remember that? So, first order neurons are dorsal root ganglion neurons. That means first set of neurons receiving the signal. So, this is first order neurons, sensory neurons. Then these neurons send signal to these neurons, right? Which structure is this? Which horn? Dorsal horn, right? So dorsal horn neurons will receive the signal from these neurons. So these are second order neurons. Make sense? Second order neurons. And then the tracts, ascending tracts, will take the signal to the brain. Which structure of the brain will receive the signal? The neurons here in the thalamus. This is the thalamus. So these are third order neurons. Third order neurons. Make sense? So if I touch here on the skin, these neurons will receive the signal first. Dorsal root ganglion sensory neurons. First order neurons. Then they will give the signal to the dorsal horn sensory neurons. Second order neurons. Second set of neurons, right? Then they will send long, fibers, tract to send the signal to the thalamus, where you have the sensory neurons, and these are the third order sensory neurons. So that's how the signal will be taken to the brain. In case of motor, so from the thalamus, the signal will go to the primary sensory cortex from the thalamus. Now, from the motor cortex of the brain, the signal will go through the descending tract all the way to the ventral horn motor neurons. So this is the motor cortex. These are the neurons. This is simple. Motor is simple. The motor cortex neurons will send long fibers to the ventral horn motor neurons. And from the ventral horn, signal will directly go to the muscle. There is no ganglion in ventral root. So from here, directly will go to the muscle. Okay. So these are called upper motor neurons. This is easy. Upper motor neurons, and these are called lower motor neurons. Makes sense? So in the motor cortex, the neurons are called upper motor neurons, and in the ventral horn, the neurons are called lower motor neurons because of their location, upper and lower. So let's quickly review. Along the sensory pathway from the skin, yes, three orders. From the skin, first the signal is taken to sensory neurons where? Dorsal root ganglion, right? Then from there to the dorsal horn. right? And from there to the thalamus, where you have third order neurons. Is it clear? Then we'll go to the primary sensory cortex. Motor pathway is rather simple. How many sets of neurons you have? Two. Upper motor neurons and lower motor neurons. Is it clear? Upper motor neurons are the neurons in the motor cortex in the brain, and lower motor neurons are in the ventral horn. You already know, right? Good. Now, this is interesting. You need to know the lower motor neurons, they are sending the motor signal to the muscle all the time, and they are trying to keep the muscle contracted. Keep the muscle what? Contracted. That's their nature. So lower motor neurons always sending signal to the muscles and trying to keep what? The muscles squeezed. Yeah. And upper motor neurons from the motor cortex sending signal to the lower motor neurons and telling them, don't do that. Okay? Don't squeeze too strong. Don't contract too much. Is it clear?
All the time.
All the time. And that's how your muscle tone is maintained. It's not too relaxed, not too squeezed. Is it clear? So you have some tone in the muscle always. Now you tell me, if lesion occurs here, these cells die. So they will get free, right? The lower motor neurons will get what? Freedom. No inhibition coming from the upper motor neurons. Is it clear? So what will happen in the muscle?
Contract.
Will remain contracted. Make sense? Because no inhibition is coming from the upper motor neurons. Upper motor neurons are not sending inhibitory signal to the lower motor. So lower motor neurons will get free, and they love to do what? Squeeze the muscle, right? So muscles will remain squeezed. That is called spastic paralysis. That will cause spastic paralysis. The muscle will not relax.
If what if you said?
Second,
If the lower motor neuron
if the upper motor neuron lesion occurs, then lower motor neurons will get what? Freedom. No inhibition is coming. Make sense? So they will do forceful contraction, and the muscle will remain like that, forcefully contracted. That is good or bad? But because to move the body parts, you need to relax certain muscles and contract certain muscles, right? So if muscles always remain contracted strongly, you won't be able to move. And that is called what? Spastic paralysis. Now you tell me, the upper motor neurons are fine. This part is destroyed. So no contraction will go to the muscle. Make sense? So muscle will remain fully relaxed, which is paralysis too, right? Muscle contraction will not occur. The person will not be able to move. So that is called flaccid paralysis. Flaccid paralysis. Okay, so opposite, but in either situation, the person will not be able to move. Now, upper motor neurons, sometimes you take your small child to a park, right? And let them run and, play. But you do what? You tell your child, don't go too far. If you see water, far, you will tell, don't go that far, right? So stay within this area. And you watch them, right? control them. Now, if you are not watching, then your child will go far, right? Will get lost. So that is dangerous. So upper motor neurons are like parents, and lower motor neurons are like children. So lower motor neurons always try to do what? Hyper. Keep the muscles strongly constricted. Is it clear? Like hyperactive, active. And upper motor neurons are like parents, telling them, don't do too much, don't contract too strongly. So that's how they work. Okay. Now, trauma to the spinal cord or transection of the spinal cord. Spinal cord injury is a very common thing in this country because, we have so many cars on the street, right? That's the main, cause of spinal cord injury, motor accident, car accident, okay? Anyway, so if transection or injury occurs in the cervical part of the spinal cord, like here, just remember when the injury occurs, the part below will be paralyzed, will be affected. Make sense? So if injury occurs here, then whole body part below it will be paralyzed. How many limbs will be affected?
2.
Here. How many? All 4, right? I said below that will be paralyzed. So how many limbs? 4 limbs. 2 upper limbs as well as 2 lower. And that is called quadri. Quadri means what? 4. Quadriplegia. Is it clear? So where all 4 limbs as well as the trunk of the body will be paralyzed. Now, if it happens in thoracic level, like here, then how many limbs will be paralyzed? Lower 2 limbs, right? So that is called paraplegia. So only the lower part of the trunk and lower limbs will be affected. And if one side of the spinal cord injury occurs, that side will be affected, right? That is called hemiplegia. So just to know that, those are the terms.
How would you basically put together hemiplegia? Like, how would you write it down?
If one side of the body
one side
is paralyzed, okay? Like injury, if injury only, destroys this side.
Like if someone has a stroke?
Stroke can also do that. That is not spinal cord injury, but hemiplegia also occurs due to stroke. Your right side of the brain controls the left side of the body. Left side controls the right side, right? So if, stroke or injury occurs in the motor part, in the right side, this side will be affected. So that is also hemiplegia that can occur due to injury to the brain.
I'm just trying to write it down so I can remember later.
Yeah. On November 14, I'll give a lecture in multipurpose room at 7 o'clock, 7 p.m. That is Thursday evening. I'll talk about my research on the brain, plasticity of the brain. Okay. So if any of you are interested to learn more, about the brain, and brain rewires the connections. This is very interesting field of neuroscience. If you are interested, please join. It's open lecture on rewiring of the brain. Okay. Yeah. Probably you don't remember. You were probably small. Superman.
Oh, wait, I remember that guy.
I remember that guy.
love that Superman.
Yeah, yeah.
My favorite part was when he got hit by the kryptonite.
Yeah. So you have probably seen, at least he was sitting in the wheelchair for many years, and what happened? He fell off the horse, from his horse, and his head did hit the ground, so the head twisted. So injury occurred in cervical area. Okay, so he got what? Quadriplegia. Okay, that means the whole body basically was paralyzed, and all of his money was given to a trust, Spinal Cord Injury Trust. They do a lot of research. Reflex, we talked about this before. If I hit here, your leg kicks forward, right? That is knee reflex, you know that. So you have receptors here. When I hit, those receptors send signal to the sensory, sensory, right? To the spinal cord. Then the spinal cord processes. So the sensory neurons will take the signal. You see dorsal root ganglia, remember that? Right? And then the signal will come here to the ventral neurons. Ventral neurons will take the signal to the muscle to kick the leg forward. Some signal will go to the brain through the ascending, but immediate response will occur here, will not go to the brain. So that is the reflex. Okay? So receptors, sensory neurons, integration, motor neurons, and effector is the muscle to move, to do the action. So that is whole pathway is called the reflex arc.
Professor?
Yes.
Yeah, and you were talking about anatomy.
Yes, yes, very good.
But we still.
Yeah, reflex is autonomic, right?
Yeah.
Reflex is autonomic. So in this case, what will happen? The autonomic neurons will process the signal and will send signal this to the motor pathway.
This means it's gonna go to the to dorsal horn, and then from dorsal horn go to the upper.
To the autonomic neurons, yes.
Oh, okay.
Yeah.
Another
Very good.
organ.
Yeah, good question. Yeah. Anyway, so I just said that in the spinal cord it will be processed, okay? Then it will come out through the motor neurons to the muscle. And this whole pathway is called the reflex arc. So there are different reflex tests. Probably you know some of those. If someone becomes unconscious, if you see the doctors do what? See the pupil, right? Light reflex, right? That's the pupillary reflex. Putting flashlight in the eye and see if pupil constricts. That is one type of reflex. Another, you all know, sometimes doctors do this, right? That is another reflex test is called the plantar reflex. You know, the sole of the foot is called the plantar surface. This is dorsal surface, this is plantar surface. You remember? Plantar flexion, dorsiflexion. So this is plantar sole. Now, what we do, we scratch the sole of the foot with something blunt, not sharp, that will cut the skin, right? So we'll scratch along the lateral side from the heel. We start from the heel and move like this, and then move towards the bottom of the great big toe, like this. And if your motor functioning is normal, when you do that, scratch the sole, the toes will flex, flexion of the toes. Make sense? It will happen like this. When you do like this, the toes will flex. That is plantar reflex. Is it clear? So that is plantar reflex, normal. Now, if you see, when you scratch the toes, instead of getting flexion, they are extended and spreading like this. That is not right, right? Normal response should be like this. Now, if the response is like this, that is called Babinski's sign. Babinski's sign. That indicates that the person might have motor neuron disease or disorder. Okay, motor neuron disease or disorder. So look at me. This is the foot, okay, sole of the foot, plantar surface. If I scratch, if this happens, this is what?
It's the normal.
Normal, right? That is called plantar reflex. Positive. If it happens like this, that is not normal. That is called Babinski's sign, is positive. Okay? So, if you test like 1-year-old baby, you do that test, you won't see plantar reflex. Why? Because the motor neurons take time, couple of years to get mature. That's why they cannot, walk. They cannot keep balance because their motor neurons are not yet mature. So you will see positive. Don't take him to the hospital. Yes.
One time I went to the doctor and she explained to me, like, I had this weird thing where if you, like, go across, like, for babies, like, if you go across right here, they'll flex your wrist, and for some reason I still do that.
Oh, you still do that?
Yeah, watch.
You don't do it voluntarily.
Not voluntary. Like, if I
Yeah.
did it to her hand, nothing. If I do it, my hand immediately closes.
Oh, this is something that
We have to do research on that.
yeah, that's definitely in your hand you have that reflex.
But it's like, when you're a baby, you have that. but
Yeah,
for
the
me,
baby
I-
has that tendency to squeeze, like like because they used to have like this. So yeah,
So for some
that
reason,
is it.
whenever I do that, my hand is closed.
Yeah, so your one is not normal, but it doesn't harm you, so you are fine. But still, it's something very interesting. Yeah.